Okay, this is Math1610, making up the lecture that we missed earlier this week. This is summarizing categorical qualitative data. I collected that data today, well, Friday, and I'm going to give you the results, but you're not going to have the actual spreadsheet to hand out to you or to look at until next week, but just take it from me that this is the numbers that we ended up getting. So first thing we need to talk about is when you're summarizing data like this, we're going to be looking at categorical data first and then quantitative data after that. The reason for that is simply that the categorical data is simpler to analyze and to make these tables and graphs, because you don't have to worry about generating classes like you do with numeric data. You don't have to worry about deciding how big an interval your classes are going to be, how many classes you want, and so on. You simply take the values of the category, those are the classes. So frequency distribution is a summary, usually given as a table, and it just shows the quantity or frequency of the items in several non-overlapping classes. Frequency just means a count. How frequent or how often does something occur? So you obtain a frequency by counting. So we're going to construct a frequency distribution table for the favorite color. And if you happen to have the spreadsheet, if I've already handed it out to you because you're watching this much later than I'm recording it, if you want to look at that spreadsheet, you can look at the different values we got. We're going to have a couple columns here, favorite color and frequency, also relative and percent frequency I'll talk about in a second. All the different colors that we had here are listed here. A couple people answered teal. I looked it up and it's actually exactly halfway between blue and green supposedly, so I just chose to make it green. Blue seems to have enough support, so anyway, I chose that to be green. But these were all the different colors that we came up with that people answered, and I just listed them in alphabetical order, and then over here I made a tally. So I just went through them and for each one of them tallied them up, count them up, and then get the frequency. You should add up these frequencies, check to make sure that you really do get a total of the 40 students. The relative frequency. So what this is you're not always just interested in the actual frequency. You know, if you say, well, there are 12 students that said it was blue, well, that doesn't really tell you that much. It depends if it's 12 students out of 200 or the 12 students out of 40 that we had. And so what you want to do is give the relative frequency, which is the frequency relative to the total number, often expressed as a percent. So if it's in units of percent, you multiply by 100 and then write it with units of percent. Mathematically, it's identical. The relative and percent frequency are the same thing. Relative frequency then is frequency divided by n, where n is the number of items or observations or values. Now here you notice I didn't reduce these fractions, so there's a reason I did that. Normally I would reduce fractions, but here the reason here is that this preserves the raw number and the total number, so you can read them from here. Usually I don't like to deal with relative frequencies. Usually convert those to percentages. The idea being that everybody has some kind of good intuitive notion of a feeling for percentages. You know, if you 7 out of 40, you kind of have to think about it for a second, but 17.5%, you have a good idea what 17.5% is, no matter what the actual total number is. So I kind of like to use the percent frequency more. So each of the 1/40th is 2.5%, so these are the percentages. You should add them up and check to see that they add up to 100%. Okay, so let's look at the next page. Okay, so two major graphical displays here. The first one is a histogram or bar graph, and this is a display where you have a bar representing each of the values of the category. And the main thing I want to point out here is notice that these bars, there's a little bit of separation between them. Okay, they're not touching each other. That's going to be different from the quantitative data. The reason for this is that with quantitative data, it's going to make sense to put them touching because there's actually values where the upper limit of one of them is going to be the same as the lower limit of the other, or very close to it. But it doesn't really make much sense to say blue is next to green, which is next to purple, next to black, and so on. So for most categories, if they're just names or labels, leave a little separation. Notice that I've done them from the most frequent to the least frequent. That's a common convention for these histograms or bar graphs with categorical data. It gives you a nice way to read off what's the most frequent to the least frequent. So I've labeled my two axes. So this is really like a graph with a independent and dependent variable. The independent variable is your favorite color. The dependent variable is your frequency. And the frequency depends on the color. You tell me a color, I'll tell you how often it was the favorite color. Yeah, so a little bit of separation between these two. I also put the frequency above each of these. You don't have to do that. The 12, 7, 6, 4, 4 here. That's optional because it's always possible to take these and look over to the vertical axis and check to see what the frequency is. Now, to make a relative or percent frequency histogram, there's only a couple of very minor changes you have to make to this. The reason being that you're really only multiplying or dividing by a number. You're rescaling everything. So when you make a relative frequency, you're dividing by the total number, and when you convert to a percent, you're multiplying by 100. So the relative size of all these frequencies is going to stay the same. So the graph is going to have exactly the same shape. It's going to look the same. All you have to do is relabel these units and change frequency to relative or percent frequency. So I'll show you what I mean here in just a second. So I'm not going to go through and draw this whole thing again. If I was at the chalkboard, I'd just erase it and put something else there, but I'll show you what you would do. Instead of having a frequency with 2, 4, 6, 8, 10, 12, now you have percent frequency, 5%, 10%, 15, 20, 25, 30%. And then for each of the bars, you put the percent on top. So instead of having 12 here, 30%, and so on. The horizontal axis is just the same. You don't have to do any changes with that. It's still favorite color, still all the same colors. By the way, I don't know if I mentioned this in this class. Supposedly blue is the most popular color that's reported, that people report as their favorite color. It has to do with tranquility and pleasant feelings and nice feelings about oceans and skies and so on. So apparently people really like blue. Here's a pie chart. This is the second kind of graph we're going to be doing. And for a pie chart, the idea is that you are dealing with mostly with percent frequency, and the entire pie is going to represent 100%. And you want the percentages for each of the different categories to represent that percent of the area of the pie. And you usually start at 12 o'clock and then go around clockwise. That's the most common convention that I can think of. And we'll again go from the most frequent to the least frequent, 30%, 17.5%, 15%, and so on. And sometimes you'll have some categories over here that don't fall into that. If you have like a not applicable or other, sometimes you'll see that at the end, even if it has a percentage that's higher than the least frequent. So I drew this with the 30%, a little bit more than 25. I kind of hand sketched this. I didn't really do it very accurately. Excel will do both of these types of graphs very well. You just tell it what to do, and you highlight the cells that have the data, and it'll do it for you. But it's a good idea to know, if you had to do these on your own, if you could do them, so you understand what's going on. Let's say that you didn't have Excel and you had to do this by hand, and you wanted to know how many degrees around the circle each of these categories would have. Well, since it's 360 degrees total around the circle, what that means is blue is 30%. That means blue should get 30% of the 360 degrees around the circle. In other words, for each of the categories, you're going to take the 360 degrees, multiply it by the percent frequency, and that'll give you the degrees for a given category. So 360 degrees times 30%, 30% of 360 degrees is 108. So blue has 108 degrees. Purple, 15% of 36. It's really late. I don't feel like doing arithmetic in my head. 54 degrees. Okay. And so on. So you get the idea, and then that'll add up to the 360 degrees total. So pie chart, bar graph. We'll come back to the bar graph when we do the quantitative data later. I'm expecting most people are pretty familiar with these types of graphs. You see them in magazines, newspapers, USA Today, all over the place. So we'll come back to these types of graphs. With the quantitative, there's some issues that you have to worry about with quantitative that don't come up with categorical, and we'll touch upon those next week. So I will see you next week, and we'll be starting the summarizing and graphing of quantitative data. Okay, have a good weekend. See you next week.